Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan, salam sejahtera untuk kita semua. Yang terhormat Ibu Luki Putri Rahayu, SSI MSI, selaku Kepala Departemen Teknik dan Otomasi. Yang kami hormati Bapak Fauzi Imadudin Hadim, STMT, selaku perwakilan dari dosen program kuliah temu ini. Yang kami hormati pula Bapak atau Ibu dosen serta seluruh sivitas akademi yang hadir melalui offline maupun melalui platform. Tidak lupa yang kami hormati pula Rektor Nazatul Liana Sidang dari Departemen Teknik Fakultas Teknik UNIVERSITI Malaya. Selaku narasumber dengan topik Design Thinking with Enginnering How Materials of System Performance and Reliability. Oke, pertama-tama marilah kita panjatkan puja dan puji syukur kehadirat Tuhan Maha Esa atas segala rahmat dan karunia-Nya sehingga kita dapat berkumpul pada hari ini dalam keadaan sehat. Sebelum memulai acara, perkenalkan saya Muhammad Maulana Pananda selaku pembawa acara pada pagi hari ini. Izinkan saya membacakan susunan acara. Yang pertama pembukaan, dilanjutkan dengan doa, yang ketiga menyanyikan Indonesia Raya, yang dilanjutkan dengan himne ITS, lalu ada sesi dokumentasi, dilanjutkan dengan sambutan, penyampaian materi oleh narasumber, lalu ada sesi tanya jawab, penyerahan sederhana dan penutupan. Untuk mengawali acara pada pagi hari ini, marilah kita berdoa sesuai keyakinan masing-masing. Berdoa dipersilakan. Amin, amin, ya Rabbal Alamin. Tiada kata cukup dalam berdoa. Selanjutnya kita akan menyanyikan lagu kebangsaan Indonesia Raya, dilanjutkan dengan himne ITS. Kepada seluruh hadirin, kami persilakan untuk berdiri.
Indonesia Raya, Indonesia Raya, merdeka
dulu kembali. Sebelum memasuki agenda berikutnya, marilah kita mengabadikan momen bersama narasumber kepada panitia yang bertugas. Kami persilakan. Mungkin Bapak dan Ibu bisa menuju ke bawah sini untuk dokumentasi. Teman-teman dokumentasi mungkin bisa. Bisa begini. Sesi dokumentasi akan saya pandu dalam 3, 2, 1. Sekali lagi mungkin 3, 2, 1. Terima kasih semuanya atas partisipasinya. Memasuki agenda selanjutnya yaitu sambutan. Sambutan akan disampaikan oleh Bapak Fauzi Imanuddin Azim, SSTNT, kepada Bapak Fauzi. Waktu dan tempat saya langsung.
Ya, lebih baik. Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam. Ya, alhamdulillah kita bertemu kembali ya teman-teman di agenda. Sebenarnya kan ini agenda yang mungkin kita lakukan juga sering kali kita lakukan. Kebetulan ini berbarengan bersama dengan kegiatan short program dan kita mendapat banyak tamu dari UM Malaysia. Salah satunya ini ada Dr. Nazatul Liana. Beliau adalah salah satu lecturer di UM di Mechanical Engineering dan fokus pada material engineering dan material science. Dan ini menjadi beliau akan menyampaikan insight-insight yang sangat valuable untuk kita semua, untuk teman-teman yang berada di Departemen Electrical Automation ini. Anda akan mendapatkan pencerahan bagaimana Anda ketika melaksanakan project-based learning Anda, mengerjakan tugas-tugas Anda, proyek Anda akan mendapatkan salah satu strategi bagaimana Anda akan menentukan, kalau di kita mungkin Anda nanti akan memilih komponen based on its material, since the material akan mempengaruhi, will contribute to the mission, the performance of the system. Sistem kalian, sistem yang Anda bangun, yang kalian bangun, itu ditentukan dari bagian paling inti, paling spesifik di material pada komponen Anda. Jadi silakan nanti jika ada kesulitan, actually dia in the process of building the project. So when you're choosing component, ya, memilih komponen, choose the component with the right material. You can create in the datasheet, or maybe you can test. Ya, Anda coba test your component and find the best component with the correct material, the best material. And Dr. Nazatul will help you. You can ask anything for your specific project. Actually, some of them they have specific topic with groups, so you can ask her. So again, thank you, Dr. Nazatul. Teman-teman silakan apa yang ingin ditanyakan nanti bisa didiskusikan di pertemuan pada waktu ini. Kiranya itu dari saya. Assalamualaikum warahmatullahi wabarakatuh.
Baik, terima kasih Bapak Fauzi atas sambutan yang Bapak berikan. Next, we proceed to the main session of today's lecture, which is the presentation by our speaker, Dr. Nazatul Liana. We respectfully invite you to deliver your presentation.
Assalamualaikum and very good morning to everyone. Selamat pagi. Saya Nazatul, tapi kamu pun bisa panggil saya Dr. Nas. Dr. Nas ataupun Nas juga bisa. Saya dari Universiti Malaya di Kuala Lumpur, Malaysia. Saya ini tajuknya untuk hari ini. Another thing, if you think that my Indonesian is weird and you want me to speak fully in English, just let me know, okay? Because my bahasa Indonesia is not so good. I will try my best to make you understand my lecture for today. I know everyone here are not from mechanical or materials engineering program. You guys are from electrical automation. Is that right? Yeah. Okay, so it seems far. It seems that the field is so far out of reach of my own expertise. But we will find some similarities that can work on. So before I begin, may I know you guys are from which year of your study? Second year. Second year out of how many years in total? Four. So you are right in the middle of your study. So I think this is the right time. So as you all know, our topic today is on design thinking meets engineering, how your materials can drive system performance and reliability. And to introduce myself, right? So I've been doing research on materials, I would say, my whole life. I did my bachelor degree in UM, and I went to Australia for my master degree and also PhD. So I work in materials, I work in corrosion engineering. Any one of you heard corrosion word before? Yes, you know what is corrosion, right? We see that all the time. Even when I was walking up to this building from the parking lot, I saw a lot of corrosion happen everywhere. So that's why. But over the years, as I work in the university, my research has expanded not only specifically on corrosion, but I also study all aspects related to corrosion, for example, coating materials, testing techniques, particularly for oil and gas industry, because we have a big industry in Malaysia for oil and gas, so there are a lot of opportunity to work in this area. Okay, so enough about me. So let me introduce my university. How many of you have been to any part of Malaysia? You, yes. Come on now. Okay. Yeah, oh, okay. I'm the mobility program. Yeah. Bila? Last year. Okay. How did you find our campus? Like, is it nice or is it?
I find it kind of interesting as well because it's really different from ITS and the system is quite different. I'm kind of interested in having my master degree over there.
That's good. That's good. In research or in coursework?
Sorry?
In research or coursework?
I think in coursework.
Coursework, okay. Yeah. I hope I see you in the future after you graduated. Okay, this is University Malaya. We are located right in the middle of Kuala Lumpur, the capital city of Malaysia. And our campus is surrounded by shopping malls, right? So we go lunch at shopping malls. After work, we spend a lot of time at shopping malls. So University Malaya is very well connected by public transport and malls and all the interesting things happening around KL. And that can be a downside for students because the attention from students will take away to all these entertainments surrounded by University Malaya. But this university has been around for so long, and we are the oldest university in Malaysia. Next. Yeah, so we are the oldest. We were established in 1905. So 1905 down to the present year, how many years? It's more than 100 years of history. But as Malaysia and Singapore split in 1963 or 62, when Malaysia split, our campus also split. right? One will go to Singapore. It's not a joint custody. It's like a total split. A part of University Malaya went to Singapore. Part of it stays in Kuala Lumpur. So the part that went to Singapore, they become National University of Singapore (NUS). Right? How many of you have been to NUS? Yes. Oh, okay. For another mobility program. Oh, okay. How did you find NUS?
Uh, it's very, very shady and cozy cooler.
Yeah. Has a very, very nice campus. Been there myself for a few times, and they have really good research going on. And NUS is the best university in Asia. And of course, it's above UM. But we work together back then, and we are still working together with NUS, even though we are totally two different entities now, right? So this is the history of University Malaya for those who've never been there. So just to give you some introduction, what we have at our department, since our department is quite big. I don't know when I say big, is it comparable to what you have here in Indonesia? But our staff alone, we have about almost 50 docents, right? 50 docents. And our students, every year we would receive about 180 students. So our program is for 4 years. So you do the 180 times 4. So every year we would be having about 800, almost 800 students in the program. So it's a very big program, and we cater to a lot of areas in the mechanical engineering program. For example, is we have solid mechanics topic, we have technical detail materials engineering. So this is my expertise. We have a lot of people working on this. And apart from alloys, Malaysia also has a big industry in semiconductor materials. So we have a lot of docents working on electronic materials, semiconductor materials, all this research related to semiconductors. We have quite a big lab and expertise on this as well. So since you guys are in a electrical system sort of topic, so if you're interested to do semiconductor for your S2, right? This is what I did for your S2. You can come and do these topics in University Malaya. We also have automation and control. This is might be your interest right now. We have a few topics. So just to make myself clear, this is not the program or degree that we have. These are the expertise that we have at our department. So we have docents that can teach all these courses. And these courses like automation, control, we also have instrumentation. So these are all courses for undergraduate mechanical engineering students. So it's quite similar to what you are learning right now. So we have control, we have mechatronics, signal processing. So these are all topics that students must learn to get a degree from this program. Energy engineering, right? Again, this another area that will cater the oil and gas industry as well. Next, manufacturing. So any of you, if you're interested in making things into the design that you need, so you can do manufacturing, fluid mechanics, design and innovation, and so on. Right. So just a brief introduction of what we have at our department. All right. So going back to, since we have about 1 hour, I designed this lecture for 2 hours. But we are finished at 11, right? Or 11:30. Okay. So I will try my best. Okay. All right. So this is the topic. Just to share with you guys what I have learned over the years, how I teach my students to view materials engineering. Because materials engineering, I don't know what's wrong with the word, but they have such a big rapport against mechanical students. Because mechanical students would say, materials engineering is hard. How many of you agree? Materials engineering are hard. Yes. Or I have no idea what I'm talking about right now.
It's quite hard. It's hard.
I googled just now. Is teknik material susah atau mudah? Atau mudah? Susah atau mudah?
Hard. Hard. It's hard.
Kenapa? Give me 5 reasons kenapa teknik material itu susah.
Because we doesn't have basics in chemical.
Okay, that's right. Okay. Anyone else wants to share? Kenapa susah? Student UM akan terlalu banyak perlu hafalan. Ya, hafalan. How many of you agree hafalan?
Yeah.
I never hafal anything about materials. Never, right? I have bad memory. You don't need hafalan. What else can you share? Why do you have this perspective of materials engineering is difficult or uninteresting? See, there are too many materials, I agree, but we can strategize on that. We will see later. Okay, so I know, similarly, you guys have such a not really a positive perspective of materials engineering, not because materials engineering is difficult, but you perceive it as something that is not affected to your work or to your study. You have less information about it, so that's when you don't have much interest in it, so you don't feel like it's important. But I hope by the end of this lecture, I can change your mind, right? Okay. So why do we need to learn about it? Who agrees that we need to learn about this at some level? Agree. Agree. Okay. Agree, right? Do you have opportunity to learn about materials engineering in your study?
Yeah.
Yes. Okay. Will you study hard and score really well for that course? Oh, so you have done your materials. What did you get for your material? A, B, How many gets A for your materials? Dapat A. Dapat A. B. AB. RB. Okay. So, okay, I will highlight you too. It's clear. I assume the others are below RB, right? Okay. So, engineering materials, why should we learn, right? All of you in this room, I'm sure, are designing something for engineering purpose, right? You want to do something that will change the world. You want to do something that functions really well, efficient. So this is your motive, right? But in order for you to achieve that, we need to have the right materials, right? So without materials, there's no engineering, right? Some of you might disagree, right? But without engineering, there will be no civilization. That is the source of civilization when you invent something. So in order for you to invent something, you have material. Even in your case, you want to do sensors, you want to do some circuit boards, you want to do some microchips, you always need to consider what is the best material that will deliver the function that you have designed. Right? Okay. Next one. So I will not go through the details of this. This is just to show you the progression of materials from the very beginning of time until the recent time, so you can see how materials technology has progressed. Right? From the Stone Age up down to the advanced technology. So we have gone through a lot of changes in materials engineering, and this development of materials now us to produce and manipulate these materials to fill our needs. That what we need in our life can be fed or can be possible by having these different types of materials. As you can see here, in the beginning, in Stone Age, everything is made of stones, made of wood, more on a primitive side of the era. As you move to the revolution, Industrial Revolution 1 and 2, when the formation of the steam engine, correct? It's very significant. Without steam engine, we will not progress to what we have right now. Right? So to design this steam engine is not as simple as designing the mechanical system of the steam engine, how it works, what are the mechanisms. Also select the best material that will deliver the function that you have designed. So that's what the word that I always ask students to consider. Right? Select the best materials to deliver the function that you have designed. Because you are very well versed in your area, you know what you want to design and you know how to design it. Right? This is just the additional item or criteria that you have to consider so that you can have a much better design in the end. Because the key is that you want a system that has a good performance and also reliable. Right? No point having something that is perform really well but not reliable over time because engineering world is harsh. Right? It's not just simple in the lab where the climate can be controlled, but outside in the engineering world, there are so many uncertainties. So we need to be prepared for that. Right? Okay, so I can skip this. I can skip this. Okay. So we know you guys know this different categories of engineering materials, metal, polymer, ceramic, composite. So when someone said there are so many materials that I cannot remember it, just remember this four. Everything will be categorized under these four main category: metal, polymer, ceramic, and composite. Right? Easy. For composite is a mixture of at least two different types of material. Could be from ceramic and polymer. It could be polymer and metal. So any combination will make up composite. So the advanced materials will mostly come in the composite category. Right? So composite will cater a lot of high performance application. All right. And to give you some idea of what are these different types of materials, so each of these family they will have a different main criteria, right? So for example, metal. Metal means metal and alloys. They are high temperature material. Is very strong. So that is the basic, right? The basic baseline properties of metallic materials. But polymer is soft, right? And it's low temperature material. Ceramic is super high temperature material. It can go up to 3000 degrees Celsius. Very strong. And composite will be a mixture of all these properties. Right? For example, you want to use ceramic, but ceramic is too hard. So what do you need to add so that you can soften it a little bit so that you can design it better? So that's where composite comes in. Right? So a lot of these high-tech materials, expensive materials, like carbon fiber composite that make the body of a fixed car, for example, is made of this composite material, where carbon fiber is composite. This is based on polymeric materials. A lot of aerospace industries will use it as well. And so it is resistant to high temperature, but still have a good mechanical properties to make it work in this harsh engineering environment. So these are the summary, right? I can talk about this topic for the whole semester of 14 weeks, but we don't have that. So this is the summary. Maybe I can share the notes later with the students so that you can flip through it and find something interesting in it. All right, so when we look at materials, so how many of you know what this is?
Yes.
What's the model? That I was a undergraduate degree student when I was a SS1 student. This is Nokia 3210. Right? Not 3210. 10 is a bit advanced at that point. This is the very first one, 3210. Any of you had the opportunity to use this from your parents or from anywhere? From
Yes.
yeah? How do you find it?
It's good.
It's basic, right? You just need to be recall just like pressing uniqueness and two buttons, I guess. So games in there. Do you know what game in there? Like
Snake.
sounds like a champion of snakes, right? The entertainment that we had, I think like there's no portable gaming like you have right now. So this is the 3210, Nokia 3210. So over the years, not that long, I used this in 2000, in 2000 and yeah, the year 2000. How many of you are already here in the year 2000? Okay, what are you guys in average? 80. 80. Okay. Alright, yeah, this was popular in the year of 2000 Y2K. So you search online, Y2K is such a big thing back then because the speculation was everything will be ruined as the clock turns from 1999 to 2000. So fake news, obviously. But this phone was so popular in 2000 onwards. I think the first 10 years of that year, 2000, is 3210, 3310, and all the series that goes after that. But now, what we have here is smartphone. We call it smartphone. So smartphone now is no longer just a normal phone, a flat phone. You can also have fold it, roll it, I don't know. So advanced. So can anyone suggest how materials made our phone smarter? How? What do they do in there? Semiconductor. What else? Transistor, the microchips, right? The design, the circuit design of this. So how can materials drive that innovation? Do you guys do circuit design? Yeah. So you know what I'm talking about. So when you design circuit, what do you consider? So the problem is you have this phone. You want you to make it more advanced and better and have more function. So you design your circuit. So what make it possible for your circuit to work the way that you want it?
Processor.
No? No answer? The answer is the materials. Right? So let's look at the next slide. Right. So here, right? So we use the typical older version of the silicon chip. Right? So with large transistors, so it's not really consuming much energy. That's why my phone back then can last for 1 week. But today's phone, with all the function that we depend on, the phones must be charged at least every 2 days, at least. Some of you might be charging it every day. So because the older phones, the function is significantly less than what we want from our phone now. So the energy consumption is very low. So that's why it's possible to use silicon chip, right? So when you design something that you want this function, that function, you want something that can charge very fast, but can last very long. So all of this will require more advanced materials to make it possible. So you have an idea how you can visualize that idea. So now we would be using all these high-K dielectric materials, gallium nitride, and so this is another top three material, gallium nitride, more expensive than silicon, of course. that will allow this nanoscale transistors, so very small ones, so that it can deliver all these functions that you have designed more efficiently. Right. And you can also have in the future, we already have it here, actually, like graphene, molecular sulfide, that can also offer ultra fast electronics in terms of the functions. Right? So, and it's not limited to the consumer mobile phone. There are a lot of electronic that you have to design in many applications like automotive, factories. If you want to do industrial revolution 4.0, which is automation, you need a lot of these chips, a lot of these systems that allow this level of efficiency. So again, you need a material to support that. Right? Without it, then it's impossible to have that. Because now we are in the AI age. AI age is Industrial Revolution 5.0. All these cloud computing, you need a big server, you need all this hardware that requires your expertise. And what makes it possible, we as materials engineers have to catch up with the demand so that we need to design much more capable materials to fit your design. Right? So we have to work together. Right? I cannot just work on my own and hope that someone might use my materials, but it has to be based on demand. Right? Next one. So next one is this EV car. Right? Fueling the future with electrons, not fossil fuel. So that's the idea. Right? Easier said than done. But for the recent technology where we have these EV cars that are becoming more popular. Even here in Surabaya, I saw a lot of EVs as well. A lot of EV advertisement. The price is quite competitive. It's okay. Not too expensive, not too cheap. EV is promoted as more environmentally friendly. Do you agree?
Yes.
Yes. To what extent? 100% agree. There's some argument to it whether how environmentally friendly is EV. Okay, so what makes EV work well? What is the main component that will make it or break it? The batteries.
Battery pack.
Right. So battery is made of what material?
Lithium.
Lithium ions. So where do you get that lithium ions? Mining. Is mining sustainable and environmental friendly?
No.
What happened? For example, these rare earth elements, right? Rare earth elements is another key element for EV, right? To make the not necessarily the battery, but the components, electronic components, and EV. So these are not environmentally friendly material or element to procure to get. But in terms of application, yes, EV is safe on fossil fuel. It will not have emission that will be bad for the environment. But when you look at the components, that's another argument. But we leave it at that. Can you go to the next slide? So lithium ion is what we have now. It's not really high tech. Lithium ion has been around for so long, right? But what we have now that we design for solid state batteries and all this another material that is up and coming is these conductive polymers. So how many of you have heard conductive polymers? All right. No. Okay. So conductive polymers also is used a lot of for these electronics in EVs. They also have some material called MXENP that is used for super fast charging. What we have now is not fast enough. All right, the researchers are designing this material to make the battery charge less than 5 minutes. Just like when you fill your car with petrol, right, with benzene. Benzene. So that is in the future. But again, what made it possible is the materials. You can design, you want how many microamp milliamp per hour battery capacity, but without the right material in your system, then it's not even a near possibility. Right? So this is just to change your perspective a little bit, as Jose mentioned that you guys are doing projects, right? Projects, you design things, you identify your problem and come up with a solution and build your prototype. So are you going to build a prototype or just an idea? Prototype. So that is a long process that will go back and forth depending on the changes that you need to do in your system to get the best possible outcome in the end. So materials is one aspect that you should also consider to have a much more better performance in the end, tailored to what you have designed. Okay, I will skip this one. I will skip this one. All right, so it's for the design process. Right, so the design process, it always starts with an idea. So some of you might have a crazy idea of doing something good for the world. So you can just write down your idea. So for your project, how did you come up with the idea? Or someone feed the idea to you? Assignment. Assignment?
Yeah, because
You spend the assignment. So this is a specific project. Okay. Can you share an example of your project? Like what is it about? This four who got AB for your materials course.
my project actually only virtual because we design a system for flow rate control in furnace system, and most of it is only a cascade control with SCADA, and that's it.
Why do you need to control the flow rate in the furnace?
Because the temperature outlet is not really stable because of the flow rate. The flow rate have gangguan in it. It fluctuates. Become a problem because the outlet temperature become fluctuate as well.
I
And we
see.
don't want that. We want the most stable temperature as much as possible.
Okay, you want consistency of temperature, so you control the flow rate. Okay, so that is your problem statement. So, but your idea, how are you going to do that? Right? So you have the problem, which is the temperature fluctuates in the furnace. So that is not good as in terms of the performance. But how can you make a change? Right? So you need to come up with an idea. So idea can be in the form of brainstorming with your group mates, brainstorming with yourself, brainstorming with the internet, whichever brainstorming technique that you prefer. So you need to come up with the idea. Right? These new ideas could be many. Right? Or maybe when you think about how I can control the flow rate, maybe there are many ways of doing this. Right? So, but it is all an idea. So from there, you need to move to the definition. You need to properly define what do you need. Right? The problem is sometimes when students do the assignments, they just do it for the sake of completing the assignment. How many of you have this thought? I want to get an A. So in order for me to get an A, I have to get it done. And no matter what, I will get it done. How many of you have this? It's same. Don't worry. Even my students have this thought. Right? So based on your smiles, I know. I know that many of you have this thought. But you will feel stuck at the end or towards the end because you are not clear from the beginning. Right? You have to be clear. Kamu harus tahu apa yang kamu mahu daripada design itu. Okay? So that's why you need to clearly define it. So you need to describe it precisely. So in this example, I changed from mechanical example into maybe something related to you. So let me know if it doesn't make sense. But for example, a system is required to monitor temperature in an outdoor industrial plant, operate continuously, transmit data wirelessly, and function reliably for 3 years with minimal maintenance. So this is what I need in my system. I don't know what I'm going to design yet, right? But this is what I need. So my design will be based on what is listed here. So this is defining the need. So in your project, try to find your need statement, right? So you already know what is the problem that you want to solve. You have some idea. Try to, I would say, quantify, right? What are the needs? So you can do this kind of product, right? So for your example of controlling the flow rate, so you need to specify what you need. So your design will be based on this. Okay. So once you are clear with this, then again, this is not a one-person work, right? So share with your team members and sit down together and discuss what you need for this particular design. All right. So once you are clear with this, it will reflect on these requirements. You need to translate this need into requirement. So in order for you to fulfill this need, what are the requirements that you must have in your system? So that is your expertise, right? So you know your area really, really well. So once you have the need, translate into design requirement. It has to be a detailed requirement. Right. So when you say flow rate, what is the targeted flow rate that you think acceptable so that you can maintain or reduce the fluctuation of temperature? Maybe it's impossible to get zero fluctuation. You will have a tolerance plus minus. Right? Plus minus how many degrees is acceptable for your product. Right? So this is where you need to list out all the detailed requirements. So you can do this for your project as well and see in the end, where did you go? Right from there. All right. So the last one. So the last one, you will have a complete product specification. So based on this process that you have from your need statement, from your design requirements, and here you will have each product specification. So your design of your circuit, of your component, what do you need? Right? So this specification guides the development and manufacturing. It's more towards prototyping your product. Right? But you need to have this. If not, you are just building things, and when it doesn't work, then you have no idea where you did wrong. Because design process is two ways. You can always go back. There's no rules that you cannot go back. Right? You can turn back the steps. So if you find something is wrong here, maybe you need to look at your need statement, or maybe you need to look at the requirements that you have listed that might be missing something. Then you will review your prototyping, right? Or your programming. You will fix something, but at least you know where to fix it. So this can serve as the blueprint of your design. Okay? Alright, so these are the summary. So this is similar concept in design process. You have the concept, your idea, your design requirements. When you do some embodiment, you write down or you draw the sketch. In your course, do you need to draw something for your project? What kind of drawing? Circuit drawing, or you just do programming? Circuit? No, the design of the product. Okay, alright. So that is part of embodiment. So you have your need statement, you have your requirements, you have all the design specification, and you will start to sketch how it looks like. Is it going to be round, square, big, small? So you will start to visualize the prototype that you want to build based on what you need. Right. And then with all this detail. So detail is more like simulation. We are not going through this, but simulation of your systems, whether if you deliver, do you do simulation for your course at this point? Do you have simulation?
It's across the simulation, like technical simulation, maybe sorry, I don't category like plan simulation.
Also, you do simulation as well. So in details, you will do some application before you build the real thing. You do simulation first to see if it works. If it doesn't, then again, if it doesn't, go back to the earliest stage and try to find what are the elements that you have to fix. Right. So the keyword here is, I like this word, iterate. Iterate, always go back. If something goes wrong, always go back to your blueprint and see how you can change it. Let's skip this one. I think we won't have time for this. So these are some examples, right? Some example of it may be related to you. For example, this electric motor. So the input for your electric motor, so you know you want to design electric motor. So the input is the electrical energy that you get from a power source, right? But the output is you want that mechanical rotation. So that's the output, and this is the input. Your design is something in the middle, right? So you know what you want, you know what the performance that you need, and what are the functions involved in this design. Right? For example, convert electrical energy into magnetic field. Use this magnetic field to create torque. Yeah, torque will move the rotor, that will move this shaft that will make mechanical component work. So that is the basic mechanical thing. But in your design, let's say you want to design a different capacity of motor, different power of your motor, so you need to find what are the functions involved for you to deliver this mechanical movement. Right? So it basically indicates how the system transforms one type of energy, in this case electrical, into mechanical movement. Right? For pumps, for fans, so these are all mechanical. I have this another example added here as well. PLC control actuator system. So the input, same, the electrical signal from the power supply. What the output that you want is the control motion. So what are the functions involved? Right? So identify a function. I don't think you have a problem in identifying functions, because when your design, you know what you need in the end. Right? You need to be clear, be specific. We are engineers, so we need to be specific on what we want, right, and what we need. And why is this? This is important because it represents a complete automation system where you have this control, actuation, and structure that works together. Logic, control logic, determines behavior, right? And maintains accuracy and repeatability over time will depend on materials. This is indicating reliability, right? So how good is your system not only depend on your programming for your controller that will determine how it acts, but also reliability from the materials used for this particular circuit board, right? So that's an example. Okay, so I have explained this earlier when we do concept stage, embodiment, and detailed design stages. So this is just extra notes that you can have. Next one. Okay, one example, right? We go layman now. So bicycle. All right. In the concept stage, right? When you think about your design, when you think about what you need, right? Your idea. First, you need to be clear. With this example, what type of bicycle that you want to design? So in your case, think about if you want to control the flow rate of a furnace, what type of, flow rate controller that you need? How big is the furnace? Is it industrial size or is it the lab size? Is it for what application? So you need to be clear application of your intended product. If you don't know the application, this will be very difficult because the application will reflect the requirement that you need in your product, okay, in your design. So in this example, can someone tell me the difference between mountain bike, road bike, folding bike, racing bike? What are the differences? What are the differences? I say
Weight.
the weight. Okay, weight and aerodynamic. Okay, what else?
Gear ratio.
Okay. I'm looking for this one ultimate answer.
Materials from the bike.
Okay, materials is different. Okay. What else? How this will reflect my design, right? My decision, what type of bike I want to design, will reflect the design requirements.
Safety.
Okay, last try. Who wants to try? One last try. What is the difference? Ultimate one.
The design by material.
Okay, it's not wrong. It's not wrong. Whatever you said are not wrong. We are all winners here in this classroom. The number one difference is the price of the bicycle. Money rules the world, unfortunately. Right? So, for example, you want to come to campus, would you buy, let me convert, would you buy a 30 million rupiah bicycle just to come to campus for lecture? No. Why? Why won't you pay that 30 million bicycle?
Right.
Too pricey. Alright, so what would you get out of that 30 million bicycle? Cycle, right? Okay, so for 30 million rupiah bicycle, what you get is performance. It's lightweight. Someone mentioned it's lightweight, right? Lightweight. You can be very fast, but you won't get tired of pedaling, going up the hill and going down the hill and to come to campus. But the cheaper one, let's say, how much is a bicycle here? The normal bicycle that is around 7 million. 700.
7 million.
7 million. Okay. Is it?
This one has so much. 1 million, I think
1 million. 1 million you can get a bicycle. Okay. Okay. So for your 1 million bicycle, 1 million rupiah bicycle, compared to 30 million rupiah bicycle, both will get you here. Am I right? And both will get you here. It doesn't matter. But the concern is, why do you need to spend 30 million instead of 1 million just to come to campus? So what this highlight is the need. Right? The need. So I only need to come to campus. I can go out early to arrive before my lecture just using this bicycle. So I only need that. I only need a mode of transportation to get me here. I don't need to compete with my classmates who can be here first. So it's not a competition. It's not record-breaking event every morning to go to campus. So it's not necessary for you. Right? So that's why reflect on your need. So if you need it, then it will reflect in the embodiment stage. Because in the embodiment stage, it says that it will select the main features as the bicycle frame, the gears, the braking system. So if you select, you want to design a racing bicycle, the high performance bicycle with all these expensive material, then it will reflect in the embodiment. That will reflect in the types of bicycle frame that you will choose. You will not choose a steel frame, right? That's something that is made of steel. But you might find something that is lighter, like composite, as a bicycle frame, because that makes sense. Designing a racing bicycle, right? High performance bicycle. But a bicycle, my selection of frame materials would be just standard steel. Steel engineering. Yeah. Got it. Yeah, that one. Yeah, the normal steel. It's heavy. It's strong, but it's heavy. So you might need more effort to do that. But you don't mind because you only spend 1 million for the bicycle. Right? So that's how it will reflect. So be clear of your need. And of course, the detail stage is more on what is the defined design of your bicycle. So that is another stage of your design. So is everyone clear on that one? How needs will reflect the design requirements? Okay, so I hope we can have some exercise. I prepared one exercise. Yeah. Okay, what went wrong? What's pointing? Okay, what went wrong? So at least 3 photos. The first one, corrosion, is box, right? It is corroded. You can see an obvious corrosion. And the other one is the chip is on fire. Is even worse. And maybe there's a damage, what do you call that, automated. Can someone help me? What is that? What is this thing called? The robot arm. The right, some damage. So in this case, what you think is corrosion? Where is that corrosion coming from? Yes, from the environment, right? So when someone designed this, do you think they consider where this circuit box will be located? Must be. But did they? No. Alright. So if you were in their position, what are the things that you will change? This is how you apply materials concept in your design. Yeah.
The basic material.
So what would you change?
The basic material.
The basic material. Alright. So what material would you choose for the box, for this controller board? Stainless steel. Alright, stainless steel is one. What else?
Maybe I will use the material from the 3D print.
3D print. What materials is there? 3D printing is technique.
Like the filaments.
Filament. What filament is made of? Can anyone help him?
Yeah.
Plastic, polymers. Right? Polymers. Yeah. That is good as well because it won't corrode. What else?
Good.
No. Okay, your suggestion is good. Alright, your suggestion is good. To use this polymer or stainless steel, those are highly resistant towards corrosion. But when you design this, when you have to deal with corrosion, you only think about the environment. So what else do you need to consider in this case? Price, right? Which one is more expensive, polymer or stainless steel?
Polymer.
Yeah, stainless steel is more expensive than polymer. But then you think again, this application, do I need something that expensive? What is the application of this controller box? Can the company afford stainless steel? Or should I just use polymer? Alright, so that's another element there, cost. Right? We discussed that earlier. Cost, type of environment. So maybe this environment is by the ocean, so we have a lot of seawater mist in the environment that lead to this. And anyone thought about the strength of this controller box?
Yeah.
If it's polymer, do you think it's safe to protect the controller board? Maybe. Yeah, that's the right answer. Maybe. So you need to understand the application. Where is it located? What is the surrounding like? What are the forces that is applied on your component? Alright, then you design better. Alright? So if this one doesn't require a high strength structure, then you can use polymer. Right? But if this require a certain level of strength, then stainless steel might be a good idea. Right? Or if you cannot afford to buy stainless steel, but you still need to solve the problem, you can buy a cheaper type of maybe carbon steel, cheaper type of alloy, but you have a much better coating or painting on the box, right? Or much frequent maintenance process, right? To take care of the box. Again, it will reflect your need. Do you need it? If you don't need it, you do not overkill your design. Right? You don't have to do more than what you need. To be practical in engineering design. Okay, so that chip that is on fire, what do you think happened? Overheating. How this chip gets overheated? How? There's not enough ventilation? Could be? Could it be? Could be. Yeah. What else? What are the other reasons? You are the expert on this one. I just guess.
Fast voltage.
Over voltage. More than the chip managed to able to manage, right? So maybe it's missing a heat sink. Do you know what is heat sink? Okay. All right. Maybe it's missing heat sink, right? To control or to manage the heat forming around your chips. So that is the problem. So what is the need that you need to specify? Alright, so maybe you need to find, you need to identify what is the application. Does the application involve high temperature or elevated temperature condition? So if it's in the computer, so your laptop will get heated, right? So some of you will put fans underneath it. So what happens when electronics get heated?
Correct.
Performance will go down. So you want to manage the heat. So that's why a lot of CPUs, they have a fan that will take out the heat of the system. So for microchip, you can have install a heat sink to manage the heat. So in your design, you need to understand, right, how much power you put in your chip, how much heat that it will generate, and in additional, what is the heat in the surrounding, right? So then you will design better. So you will have your need, what are the requirements, then you might introduce different types of materials or another additional component in your design to manage this heat problem. Right? Okay, so the next one is automatic the automation, the robotic arms. Right. The robotic arms, let's say it's broken, right? As it in operation. So what happened? What could be the possible reason that it is?
Maintenance.
Maintenance or lack of maintenance. Okay, what else? What would be the answer? It can be anything. Anyone, don't be afraid to share what your thoughts are.
Maybe the arm working too hard until
Working too hard beyond capacity.
yes.
Okay, what else? That's a good answer actually. Right, let's go with that answer. It works too hard, right? Even as human, when we work too hard, we'll break down sometimes. Right? We need some time to cool off and relax. So same goes with machinery. Need some maintenance, some period to cool off. Right. So when you have this problem over capacity or overuse of this component, when you're in your design part, right? What is the need you need to specify? So you want something that can last longer, can work harder in a long hours. So how does that reflect your need, your statement, and your design requirements? How? Okay, so I will share the answers. I could be wrong, but we can discuss. All right. So when you want something that will be more reliable, right? Is you're not going to require the programming that you have done that set up for these robotic arms. You also need the physical strength of this arm so that it will last longer. Because your programming will last forever. Right? Maybe you need to do some debugging sometimes as part of the maintenance. But what is required in this example is a material that is more reliable, right? To make sure that it is well suited your programming of these robotic arms to work longer. So you need much stronger material, right? Maybe in the beginning, you designed it using steel, right? Because it's cheap. So in terms of manufacturing cost, it will be very low. It is very attractive. But if you need something that works in a longer time, you may need something that is lighter, right? So it will not burden the system, especially the joint here. All right. So you need something lighter but something strong. So what are the options that you have? So it will reflect your needs. So you need to work. You need this robotic arm to work long hours. Specify how many hours without maintenance, with minimal maintenance, and so on. So these are your needs, your requirement, and how it reflects the change of materials is that you might end up using, for example, aluminum alloy. Aluminum alloy is light but strong, right? Maybe not as strong as steel, but then you need to reflect what do you need in your design statement. So these are all options that is not necessarily, it's open-ended, right? It's not necessarily wrong or not necessarily 100% right. So everything will have to be justified. So these are the circumstances that might reflect your need statement that change everything, right? Change how you perceive design and how it helps in selecting much better materials for better performance. And the most important thing is reliability. Is your product reliable? It's good. It's good. I mean, if it's good performance, then it's not enough, right? For engineering, it's never enough just depending on performance. You must have reliability of your component, of your product, so that it will be a much better design for engineering application. Okay, so I will skip this next one. These are all boring things on how we can do selection strategies. But what I need you to do is the activity that I prepared on this slide. Can you go to the next one? Next one. This is example of the heat sink that I have. Do you have a way to share the notes with the students?
Yes.
Okay. So we can have these notes. I authorize all these notes for you. These are all taken from my own different courses in my lecture. So I compile it and put it together. But this is another example of how you can identify the function of a heat sink that will help manage the heat forming within your systems. All right. So let's go to the next one. Okay, the first one. Any question? This is your time. Yes.
Thank you for your time, Lunas.
Yes.
I'm Alex from second year.
Hi, Alex.
Lunas, me and my team are currently researching shape memory alloy wire actuators for robotic reapers. Assigned by our lecturer, Mr. Dteo'S. I think you may have met him for our project-based learning this semester. And the major challenge is in that SMEs suffer from thermal fatigue and degradation after thousands of actuation cycles. Based on your expertise in alloy durability, how do you apply internal design thinking to either treat the surface or better manage the thermal stress to improve the long-term reliability of these actuators?
Okay, thank you, Alex, for your question. Okay, I will not give you exact answer because that's your assignment to try the answer. But what you mentioned, you want some fatigue elements, fatigue criteria, all these properties. That is what you need, right? That is what you need. So you are very clear on what you need, right? So what is the requirements here, right? So look at the materials, which one that will have the level of fatigue that you want. So in your design, what is the value? Right? You cannot just go general. This is what I always remind my students. You might say that I want something highly conductive. Then how conductive is your need? So you need to quantify. We are engineers, we need to be specific. So you need to come up with a range of values so that it will guide different materials that is available. Because not everything will fit into that particular range. Does that help, Alex? I think we can discuss. Show me. I think it's better. No. Anyone else? Anyone else? Okay. Last call? Last call? No? Okay, I will make a round and talk for everyone when we do our class activity. So if you still have questions but too shy to ask in front of your classmates, we can discuss later. Can you go to the next one? All right. So this is the class discussion or activities. We can do it in groups. Up to you. You can do based on the table, or you want to combine the tables together to discuss. It's flexible. So work in a group, analyze the given scenarios in the next slide later, using a simple design thinking approach, and identify the main environmental operational challenges. Propose few materials options and select one with clear justifications based on performance and reliability. Alright, so if you select the wrong one, what could happen? So that is another aspect when you consider the risk of getting the wrong one. Alright, discuss in the group, alright, and then one of the member of your group, selected group, um, should present your ideas to the class. Alright, so let's look at the scenarios in the next slide. Alright, the first one, conveyor system rollers, robotic arms component, outdoor smart sensors. So these are three scenarios. Right? We have three rows. Maybe this row will get conveyor systems. Right? The one in the middle is robotic arm component. The last one there, outdoor smart sensor. Right? So the grouping up to you. You decide how many in your group. Or you want one group for the whole row. Go ahead. No problem. Find out if this line open on this screen, so you can start discussing with your members how you can solve this, come up with some ideas that we can share in the class. So I will walk around and talk with everyone, see if they have a problem in doing this. Okay, all right. So let's get to it. We have about half an hour. Sorry?
Saya kan ada dunia sekarang sudah ada satu dua dan itu orientasi harus seperti ini terus kau ada setelah pergi sepeda motor kalau sudah tahu kita kayak belum saudara sama lu kan
41. 41. Başımda. Ama that's những bộ phim là I biết trường like tao có thể từ 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 đây có một bạn không biết biết
Mati belum sudah. Oh, lagi 15 menit. Lagi 15 menit, jadi saya akan panggil yang bernasib baik. Berhadapan.
Ilang ibang mas tahu Sekarang masuk aja sekarang mas ya mereka tahu hello 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 Nanti tadi nanti tadi Gimana sih itu berbagi juga bagi beban ya kalau ini
As soon as they saw the question appear in the screen, they will take photo. That's step number 1. Can anyone guess what is the step number 2? In ChatGPT, find the answer. Right? See, I'm like a pre-AI generation, so I know the trick. Okay, so I know students will do that. I'm prepared for students to do that. But in order, when you run the questions through ChatGPT, there will be a generic answers. Right? I have run my question in the ChatGPT, so I will know what will come up of ChatGPT. Okay, the value of the activity, right? How well you can explain it. Right? That is your insight. You cannot get it from ChatGPT. Right? When you present, I will always ask questions that you might not expect, that you might need to do a little bit of thinking. So if you guys have done it honestly without using ChatGPT, I'm sure you can answer the questions. But when you depend too much on ChatGPT, then it's like a robot, right? You are just being fed by the answers, but not necessarily that you understood what ChatGPT is telling you. Right? So I'm not stopping anyone to use ChatGPT. I use ChatGPT all the time. But make sure that you are ready to explain. Right? Always learn more than what you are given. Okay, so with this, I will call out. Or you want to volunteer or me calling you out? Sharing your answers with your fellow friends. Let's see who refused the eye contact. You better look into my eyes if you do not want to present. Okay, like I want a smart sensor. So eye contact. Okay, this guy is sweating. So let's see what he has. Okay, grab the mic. You can just talk to your friends. If you can talk in Indonesian or in English.
Dan saya sekarang duduk di semester 4 tahun kedua. Oke, jadi untuk case yang ketiga itu sendiri kan outdoor smart sensor ya, di mana kita disuruh untuk mendesain sensor temperatur dan juga kelembapan yang sistemnya itu wireless, dan juga sensor itu dioperasikan selama with minimal maintenance while exposed to high humidity, rain, UV radiation, and possible salt spray. Terus the enclosure bisa dikatakan sebagai wadahnya sendiri itu harus bisa melindungi internal dari electronics, melindungi dari korosi dan juga kelembapan. Dan di sini saya use AI, dan di sini jadi ada 7 material yang dimana intent materials ada semiconductor, kemudian konduktor, isolator, polimer, keramik, komposit, dan juga elektroniknya. Untuk material semiconductor sendiri itu sebentar.
Jadi material semikonduktornya itu yaitu silikon. Fungsinya yaitu untuk mengontrol aliran elektron secara presisi. Kemudian dari konduktornya sendiri itu yang berada di enclosure-nya itu mengalirkan listrik dan sinyal dan juga dari track PCB hingga baut enclosure. Jadi untuk bautnya sendiri itu mengandung konduktor. Terus
Oke, kamu pasti nggak apa yang kamu baca? To be
little.
honest, okay, a little bit. Okay, have a seat. Sit. Continue. Thank you for your presentation. Continue. Biar sambung.
Okay.
Alright. Thank you for your presentation. Okay, looking at this statement, these are need statement. If you notice, any one of you notice this is need statement that you have to come up with your design requirements before you end up with your materials. Anyone notice? No. Okay, that's fine. So this is the need statement. So this is what you need. So how do you translate that into design requirements in detail? Alright, for example, it needs to have a resistance towards humidity, rain, UV radiation. So you need to make an enclosure. You know that this board will be outdoor, right? This sensor will be outdoor, right? So what kind of material that you can use, right? What are the requirements that you have? Right? It has to be corrosion resistance, right? It has to be resistance to UV as well. So it is an enclosure, right? So you need to come up with what materials you can come up with the enclosure. And since you are the expert, if it is enclosed, can sensor still move? No, because sensor is sensing the environment. So how can you come up with smart solution for this one? Right? You want it to be enclosed, but you need the sensor to work as well. So is it required to be totally closed or partially closed to protect it against this environment? Right? So that's how you look at it. So this is the condition of the environment. You understand how sensor works. So how you can combine these two knowledge. Right? So once you have the detailed requirement, then you can shortlist your video. Okay? Alright. Anyone else wants to attempt from this? Or have a similar answer to mine? No. Okay, that's fine. Alright, well done. I think you did a good job with that ChatGPT. Alright. I will give you 4 out of 10. Okay, 4 out of 10. Okay, robotic arm. So anyone attempt on this one? Eye contact. You, yes, you. Yes, you. Yes. Alright, so please give a short presentation to your classmates. What is your finding for this work?
Good morning. Let me introduce myself. My name is Maul Salwa Maulida. You can call me Naomi. I'm in second year now. Even though the Vietnam's component, I think aluminum alloy is a good choice because it is light, strong, and durable. It can even improve speed, precision, and long-term reliability and robotic arm system. Compared to carbon fiber, aluminum alloy is cheaper and easier to manufacture and repair. Even though carbon fiber is lighter and it's stiffer. Stainless steel is stronger and more corrosion resistant, but it is functional heavier, which can reduce speed and efficiency. So, aluminum alloy is the best balance between weight, strength, cost, and performance for industrial applications.
Okay, thank you. Now we okay, thank you presentation. You can have a seat. Your answer. Okay, it's not wrong. Stainless steel, but it can also mean you can also use carbon steel and other type of steel. Everything can be justified according to this need statement. Okay, interestingly, that now we mentioned corrosion. Is it necessary in the need statement? No, because a lot of these robotic arms is operated in the closed environment, in the building, in a factory with air conditioning, for example. So it is protected from the environment. So the question is it necessary to put corrosion as one of the criteria? Not necessary, right? If you remove corrosion, you may end up with more choice of materials because you only focus on the mechanical strength of the material. For example, stiffness, the lightness of the material. Okay? So you did well. Well, I will give 6 out of 10 for that one. Alright, well done. Okay, the last one. Okay. Give your hand up. Alright? Okay, last one. Conveyor system rollers. Who wants to volunteer? Should I look at your eyes? Anyone? Any volunteers? You want to volunteer? Yes, please. Can someone give me a mic?
So, first of all, let me introduce myself. So, my name is Mega Wijaya. I'm in here first year in the second semester. So, the first question is conveyor system roller. In here, we must know the condition is the condition conveyor is we must find the material for the under moderate load and are subjected to friction and wear and the operate continuously. So the material must ensure durability, reduce maintenance, and provide consistent performance over time. So in conveyor, I choose the hybrid components when the apa namanya? Ada apa ya? So the in conveyor, I'm use the steel material, and for the outer, I choose the polymers. When the polymers can be safe for the friction and wear, and the stainless steel in the conveyor is for the durability and provide to consistent performance over time. So the hybrid component is the solution for there's apa namanya? Iya, yang jadi dari material hybrid itu adalah solusi buat dari parameter yang diminta dari conveyor. Thank you.
Thank you. Sure. Right. Okay. Statement. It's the rollers. So the wheel. Right? Those rollers, a chain of rollers installed throughout this conveyor belt. So we are not looking at the belt itself. So we are looking at this roller system, right? So this roller system is already stated that it's moderate load. Maybe something that is not so heavy. So you do not overkill in your design. So you don't have to go highly strong material. Right? I agree, you can select steel. So steel is economical, it's cheap, it's strong, it's heavy, but weight is not constant for roller because it is stationary. It's stay put at the same place over time. So that is not necessary. So you just look at the strength and also friction. So how is address friction and wear? How? How do you address friction? Friction.
Second.
Gesekan, ya, gesekan. Address gesekan.
I choose the polymer component
Okay.
because for the strength I choose the steel for the inside, and the outer I choose the polymer for the friction to be smooth than steel.
So when we deal with friction, friction will cause a layer of a metal surface to be removed, right? So that is not good over time. And you need high strength surface to solve this. And polymer is a soft material. So polymer is not the right material, right? So you can have a steel made, a wheel made of steel, but then the outer you can apply ceramic materials. Because ceramic is a very, very strong material, right? So when outer side is ceramic, it still resists friction and wear, so it will be designed much better, perform much better. Right? So you can still have steel wheel, but the outer you spray it or you treat it with a ceramic material. So you get high strength, you can get high surface hardness. What do I say surface hardness? Kekerasan permukaan of the roller. So that can solve the problem. Alright, so again, very good discussion that I see from everyone here. Some of you are more than the others, but that's okay. This course is not needed. But just to introduce some new perspective that can help with your design project, not only now, but later in your study. Okay? With this, I will end my lecture. It is such a pleasure to give lecture to you here in this classroom and also those who join us online. I appreciate it. I enjoyed this session, and I will end my lecture today. Thank you very much to everyone paying attention or not. It doesn't matter. I appreciate everyone equally. So have a good day, everyone. So I will enjoy the remaining days in Surabaya for sure. And if you still have more questions to ask, you can feel free to come forward later. Alright, so with this, I end my lecture. Terima kasih. Dan Assalamualaikum.
Okay, thank you so much for our speaker, Dr. Nazatul Liana. For the knowledge shared today, we hope the insight provided will be beneficial and inspiring for all of us. Next, we will proceed with the topic of appreciation as a form of gratitude from the Department of Electrical Automation Engineering to our speaker, followed by a documentation session. Mungkin selanjutnya adalah sesi interaksi drama kepada Bapak Mari ya. Dan dokumentasi ini ya soal pembangunan komunikasi. Kalau udah sana gue mau dikit kan. Sisi dokumentasi akan saya bantu dalam 3, 2, 1. Selanjutnya 3, 2, 1. Jadi selanjutnya 3, 2, 1. Oke. Sekali lagi mungkin 1, 2, 3. Baik, terima kasih banyak kepada Dr. Nazatul Liana yang juga mewakili atas
Thank you everyone.
Mungkin bisa tepuk tangan dulu harus belum. Yeah, finally we have reached the end of today's guest lecture. We would like to express our sincere gratitude to the speaker. And all parties who have contributed to this event, both offline and online. Kami juga mohon maaf bila ada kurangnya. dan juga salah kata mungkin mohon dimaafkan. Terima kasih semuanya yang sudah hadir baik offline maupun online. Eh, Selamat pagi dan wassalamualaikum warahmatullahi wabarakatuh.
Selamat.